They talked about SaaS, but we are actually working in a PaaS, platform as a service, straight Kubernetes, Mesos, and that kind of a thing. Typically, when we talk about SaaS and PaaS, right, we talk about IT, information technology layer. We are working in a communication technology layer, CT. So the requirement for IT and CT are a little different. In the sense, in the communication, what happened? We have applications of real-time data, right, voice or real-time video. So it is not like a typical web application, right? You have a web tier, then a application logic, then you have a database tier. So when you think about cloud means that's what is cloud, right? Web tier and database tier. That's not only the cloud, there are so many other kind of applications out there. So we are working in a telecom world where applications are something like, you have to virtualize a network function. For example, a firewall, that's a network function. Routing, it's a network function. Switching, that's a network function. So in our world, we cloudify all of the network functions. Okay, so there is something called radio access networks. You know how the mobile towers works and all these things. So we supply all the equipments. So far, before the cloud happens, right, we basically talk about hardware boxes. Now all those boxes are gone. Now those boxes are becoming software stacks. So how do we cloudify that? So the challenge in Huawei for us, it is much, much higher than the traditional world of IT. So what we are going to talk today is, of course, we are recording, right? It's not official Huawei thing or anything. Okay, our personal way of telling what we are doing. With that, we'll start. My name is Krishna. Dhilip, my colleague. We work for Huawei. I told you we have a cloud team at here in Bangalore R&D Center, around 100 people, 80 to 100 people. So I'm leading the team. We have other geographical locations also, like US and other places. So we have fairly a large number of people working on the cloud. Okay, I said that. How many people heard about Huawei Cloud? Good, I know that nobody has. The reason is we don't have Huawei Cloud in India. Okay, we have Huawei Cloud in China. It's a public cloud, just like Amazon Cloud, and we have not launched in India. But we have private cloud services we are giving to a lot of telecom providers. I'm not going to tell any telecom or our customer name here, but
especially when you're recording.
Yeah, recording. but lot of large telco providers are our customers. So you can think that, including India, there are large players actually. But I will not take that. Okay. So we talk about stateful set. Why stateful set? Hey, something. You have to do something. Okay. A lot of things in our agenda. The first maybe 5 or 10 minutes, I'll give you a brief introduction of what is stateful set. Then Dhilip is going to show a demo how we are using stateful set in one of our customers' site. Okay. If there's a stateless application, let's say typical web application, okay, there are already replica sets available. You guys maybe know replica sets, okay. Then these replica sets are typically called, these stateless applications are typically called K8s. K8s, because it just takes care of its own, right? You just give some food and K8s will take care, right? But if you want to stateful applications, you need to have some specific activities has to be done. So that is why these are called pets. So initially when Kubernetes comes out, like 1.3 time period, they were calling this as a pet set. Then by 1.5 Kubernetes, they renamed this as a stateful set. Okay, so probably now it's called a stateful set. A lot of things are written here. I'm not going to read. These slides will be shared actually. Okay. By the way, anyway, we are not here to learn the theory, right? We are here to learn what practically we are doing, kind of a thing, right? So theory you can even read. But the difference is, so this is the difference. There is a stateful container and there is a stateless container. Okay, there are two kinds of a container. So typically, you don't have a connection with the disk.
Krishna, sorry to interrupt. One thing I would like to add is that the reason why the name was changed from pet set to stateful set, there is an enormous argument that has happened in the community. There is one issue which I would like to post it to the meetup group, so you guys should go through. So one vegetarian probably, he posted an issue saying that, I mean the concept of pet set is that it's okay to.
Probably in Indian actually.
Yeah, I don't know, maybe he's a Chinese Buddhist also, or a vegan also. So the concept was that it's okay to kill cattle because you bred them for that, and it's not okay to kill pets. So pets are more special for you. So, but in a humanitarian angle, that's not okay, right? Both are living beings, and you cannot differentiate, discriminate it based on what you eat and what you don't eat.
Yeah,
So
yeah.
beautiful argument, but if you want to really kill time.
Yeah. So
try that.
I think whatever the reason, right? Now it is called stateful set, but the idea is you think like the cattle and pets only. It needs a lot of special take care, right? You have to take care a lot of things special here. That's why it is called stateful or pet set. So you can see this is a typical world. When we talk about container, you think like this, right? A persistent storage will not be there, and there will be web front end will be deploying so and so. But when you come to the stateful set, you can see you have secrets, you have databases typically, or logs has to be taken care, and so on and so on. In our telco world, when we talk about cloudification of network functions, this is very important. When delay is very important. It's like 1 millisecond delay will create a lot of problem. It may not create a problem in some applications, but in telco world it creates a lot of problem. So we deal with that kind of applications. Okay. Let's go. Volumes actually, when we already covered volume, so I'm not going to cover the volume, but there are several kind of volumes are there. We also use some of the NFS, iSPC kind of a thing. Flocker is there, very popular. Cluster-FS, I think Red Hat guys are using actually, right? So there are so many volumes are there. We already explained. Okay. So this slide I thought I will put it. There is a concept called cloud native, and there is a concept called microservices. And there is something called 12-factor app. How many people know all these things? What's the difference between these? Can anybody say what's the difference?
Difference, I'm not very sure.
You heard about, right? So I asked the question you heard about. Okay. See, 2 days back there was a webinar with the VUWorks CEO, Alexis. He had a webinar. So somebody asked this question. So what happened? So he said it depends. It depends. There are a lot of ways you can explain. So there is something called 12-factor app. Okay, 12-factor app comes from the world of Heroku. Okay, Heroku, Salesforce is what Heroku right now. 12-factor app is mainly for how you deploy an application. There are 12 factors are the application has to be descriptive, it has to be portable, logs has to be properly taken care, build should be different, deployment should be different. There are 12 factors are there. You can go to 12factor.net. You can get that 12factor.net. Okay. So 12-factor is the one way of deploying cloud native application. One way of deploying cloud native application. For example, Cloud Foundry. Cloud Foundry you guys have heard, right? It is a one way of deploying cloud native. Sometimes in our world we have to deploy some streaming applications. That is not a 12-factor. So streaming application can also be a cloud native. So cloud native is what it is. It's the pattern. It's a pattern. The way you deploy application, that's a cloud native. But a lot of time when containers, right, we talk about microservices. Microservices is an architecture actually. It's not a pattern. It's an architecture how you organize your application and how you deploy your applications. So containers or Kubernetes will help you to deploy a microservices architecture. So that's a typical difference actually. So these are different. Cloud native and 12-factor and microservices are kind of interchanged and used actually. But when it comes to the Kubernetes world, it can all put together. So that's why I thought I'll put the slide here. Anybody have any question on this one? And also, most of the time in the Kubernetes world, Go applications is used, right? Go language is used. Not necessarily cloud native has to be Go. It can be anything. It can be JVM based, or it can be any other language based. That's another difference. For example, Netflix OSS, right? Yeah, that's all pretty much. And there is something called serverless. There is serverless coming up. Initially we had bare metal machines, right? Then we went to VM, virtual machines. Now we are going to containers. Now from containers we are going to serverless actually, right? So maybe after a year or two, we may not be even talking about containers at all. In fact, we are working in one of our project serverless actually. How serverless can be like Amazon Lambda function, right? How serverless can be used in a telco world. So where, as an application developer, you only deal with an API. You don't care, right, whether container is being orchestrated this way or that way. You know how you have an application, you have to run it. So you just go say, run my application. The serverless will take care. So in the future, that's going to be done. So cloud native can also be in serverless. That's the one way of deploying cloud native. Okay. And there are unique kernels are coming. So maybe in the future we'll be talking about unique kernels. I think may not be containers. Unique kernels in systems and applications are being called unique kernels. All right. No question.
There's an incubator project for such one of the unique kernels, I think.
Yeah.
In Kubernetes.
So it's very fast moving change. Serverless and unique kernels are taking over. So serverless is definitely taking over actually. We know that actually. Everybody's saying serverless. Like Amazon is having Lambda, Google is having Google function, Azure functions, and IBM is having OpenWhisk, which is open source anyway. If you want to know what is serverless, you can go to GitHub and see OpenWhisk. So we talk about some of the use cases, right? That's the case, use cases. So this is, I just took from one of the website actually. We are not really processing any Twitter applications or anything. So this is a typical way, you know, this is stateless web and a stateful DB. So if you don't know what is stateless and stateful, you can put that in web and DB. And these are the Kubernetes reports. Okay. And one of the things in our world, actually this documentation is there already available in Kubernetes. How to deploy a zookeeper. In a real world, Hadoop world, right? Hadoop cluster, there will be n number of clusters will be there. There will be name node, there will be n number of data nodes, then there will be a zookeeper for having a quorum and to maintain the Hadoop cluster running. Okay. So Kubernetes is being used nowadays to maintain that kind of a environment where Apache Hadoop and Kafka can be deployed and zookeeper will handle all the things. So one of the deployments, you know, this is how the things are set up. We don't have much time today to explain deep down, but how the things are set up is already documented. It is not exactly the way we are using, but just to give an idea. This also I got this diagram from one of the website actually, just to how multiple MySQL services are deployed with the web front end, WordPress, just to show you can have single instance in a stateful set, and you can also have multiple instances in a stateful set. Just to give an idea. So if you don't know what is stateful set so far, you think like some services has to be deployed, and it should have a persistent storage, so that it has to go down or it has to be connected to multiple ports or container. You should be able to connect and sustain that connection, and it should be running. So the state of the application has to be maintained. That's what it is. So Kubernetes can be used for both kind of stateless world as well as stateful world. So now we will talk about a Redis deployment in our world. We in our world use a lot of applications, including Hadoop, Kafka, Redis, MySQL, and so and so. And one of the deployment we'll talk about how we are using Redis. So that's what is the introduction actually, and he will be showing a demo. Do you have any questions? Anybody have any questions? You should know basically what is a stateful set. At least if you walk away from this meeting, just to have that, what is a stateful set, that's good enough. You don't have to know deep down what is a stateful set. So containers are there, we can deploy stateful applications. Any questions? No? Okay. So Dhilip will go for a demo. How is stateful application?
So Gaurav asked initially, did you guys evaluate Kubernetes before any other technology before choosing Kubernetes? So we also were in the same crossroad. So I think we started evaluating Mesos and Kubernetes end of 2015. So at that point, Kubernetes was not really up to the mark. Things that not what we wanted to do in Kubernetes. It was not supporting. So most of our internal applications were stateful in nature, but they were all telecom applications, so they were also latency critical. So they have very less tolerance towards latency. So stateful in the sense there are two ways of statefulness, right? One is that you store everything in disk and you have everything in your memory. So this was the latter. So disk statefulness was okay, but in-memory statefulness is very hard to maintain, especially at that point in end of 2015, Kubernetes had only replica set and services to expose replica set. So when we tried the easiest translation or the equivalence in the open source world is Redis. So which is stateful in nature, which is in memory, which is absolutely fast, and which is very, very less tolerant for latency. So we started writing a scheduler for Redis. So we called it Mr. Redis, and that's now part of Mesos ecosystem. If you go to Mesos/Mr. Redis, so we contributed that.
Actually, their answers were very surprising. 2 years back, Mesos was better, we felt, compared to Kubernetes. Now Kubernetes is catching up. Actually, it is actually something like that.
So at that point,
the product was better.
It was better. We felt the Mesos was better. And we were actually working with. In fact, I want to say, Dhilip is one of the Mesos committer from our team. You know, committer means a person who goes one stage. Initially, to be a contributor, you go contribute to the open source. Next stage is a committer. That means you will give access right to the repository. So then the other people, when they contribute, he will be the person accepting that and merging to the main track. And then the next is PMC, like project manager, something like that. So he's one of the.
So this is our I mean, Mesos has got two areas. One is that core Apache Mesos. So I'm not a committer in core Apache Mesos. So my project got merged in the Mesos community projects. So this is.
It's not called Mesosphere. There's a company called Mesosphere, right?
Yes.
Yeah. So he's a committer. So you're going to show that, Mr. Redis?
Inviting contributors.
So he contributed quite a lot in that, Mr. Redis. He wants to show that. I mean, it is good contribution, appreciated by community, and just like Mr.
Yeah, but.
That's what I was not able to move that actually.
Oh man.
Okay, go back to the person.
You can't type in the demo also.
Yeah, only enter was working. It was not moving.
But demo.
Demo, how do you do demo?
I have no idea how to do it.
This is a typical case, right? Any demo when you are doing, something has to go down actually. Then only that demo is really good demo.
So the main advantage of Mr. Redis scheduler is that it allows you to deploy hundreds of Redis instances in less than a minute. So we tested it. The original Marathon framework was container based and it did not allow us to do it. So if you have a Redis binary or if you use Alpine Redis image, then you could easily spun up a Redis instance in less than 10 seconds. That was very critical for us because we need to spun up applications, instances in a very short period of time. And so when I started working in Kubernetes like recently, like last 3 weeks, so I'm really involved in the community, trying to understand what's happening, and then Stateful Set is the area I'm trying to focus. So I'm attending the SIG meetings, so I invite you on to attend the SIG meetings. It happens every Monday night. So that is where Stateful Set scope is. So in that, what I saw that the current Redis pet set is completely based on persistence. So I thought, why not I rewrite the pet set or the stateful set without persistence? It is quite a challenge. It is not as straightforward as we think in Kubernetes. So when you remove persistence from Redis, so let's take a simple master and slave example. So I'm going to draw here. Let me try and draw it as big as possible. So you have a master and you have multiple slaves, right? So people are familiar with Redis? Anybody who's not familiar with Redis?
It's a key value store, right?
It's a key value, in-memory key value store. It's one of the fastest in-memory key value stores.
Right.
So the problem with Redis is that the moment you enable persistence, the performance drops like 30 to 40%. So that's not really tolerable, right? I mean, you choose Redis because of its performance nature, but then you lose performance just by enabling persistence. So the current pet set in Redis, in Kubernetes, which has been contributed, how it does that? It has a PVC, it has a PV back. Then same thing, everybody has a PVC. So there is a disk persistence enabled. So you start a master and slave. So like Krishna said, Stateful sets properties that your pods are being started sequentially. So when we tested in 2015, the paths, you have no control in pods. So you cannot add new elements, you cannot scale. So whatever replica set you start, the number of containers in the pod, you cannot change even now. But still, everything will start at the same time, which is like you have no control, right? So we needed more control for a stateful application. So that's what stateful set gives you. So if you start a stateful set with 5 pods, then each pod is started sequentially. Each pod gets an ordinal index. Like if your stateful set name is cache, then it's cache 0, cache 1, cache 2, cache 3 until the number of replicas -1. So if I name my Redis replica, Redis stateful set as cache. So this would be 0, index 0, 1, 2, and 3. So with persistence, it will start like this. So when this pod goes down, so you go with managed schedulers because you want it to be fault tolerant in this level. Right? When something goes down, Kubernetes will try to bring it up. When it brings up, it will read everything from the the disk, and then it's repopulate. All the slaves will again attach to the same master. It will start replicating. So it's pretty straightforward to do this. But when you remove this, right? So you have like 5 GB of data here, and everybody has replicated 5 GB, and then something happens, and then this guy goes down. Now Kubernetes will try to bring it back. So now there is no persistence. Kubernetes will bring it back with 0 memory. These guys will again start replicating. So your 5 GB Redis cache will become 0 instantly when the master goes down. If a slave goes down, it's pretty straightforward. Kubernetes will bring it back. It will attach to the same master, repopulate 5 GB in no time. That's pretty easy. But if the master goes down, then one of your slave needs to be promoted as a master, right? So for you to do that, you need to use something called as Redis Sentinel. Redis Sentinel is another big root. So to configure Redis Sentinel itself, you need a proper configuration file. It needs its own PV and PVS. So it needs to remember how many Redis instances are there in your stateful set. So that, and you need more than one sentinel to do the master slave promotion effectively. So if you have a stateful set of 3 Redis actual servers, you might need 3 sentinels. They can talk to each other to decide whether the master has gone down, whether who needs to bring up, who's the most current slave, all these things. But bringing back the actual Redis itself is done by Kubernetes for you. The service discovery, the endpoints are always done by default done by Kubernetes for you. The only thing that Redis Sentinel would add value here is slave promotion, right? Just for slave promotion, you cannot have more than one Redis. You don't need to have more than one Redis Sentinel in one stateful set. That's like overkill, like really overhead. So what we did is that we rewrote Redis Sentinel, which will only do slave promotion. It exactly does the same logic. We rewrote the Redis Sentinel for doing slave promotion, and we called it Redis Sentinel Micro, just for Kubernetes. Small portion. So what we do is that one thing that Krishna did not mention is that there is also a facility called init containers, which was brought in exclusively for stateful set. So init containers are not actually a part of stateful set, but they were brought in as a property of pod. So in a pod spec, you can have a sequence of steps, containers you can run, and you can call it as init containers, and they could probably populate your config file where your main app containers can consume. So what we do is that we start this, we run this Sentinel. Redis Sentinel Micro is idempotent, so I would love to show you. So that's also open source if my keyboard works. So Redis Sentinel will be started in init containers. So it will go and see all the Redis servers and find out who's the most current slave. If there is a master and slave are configured, and it won't do anything, it will simply come off. If there are only a lot of slaves, then it will select a master, and then it will write a config file of the new master. So the app container, the actual Redis container would come up in your stateful set. That would go and read this config file, and it will find out that there is a new master right now, and then it will connect to that master and start replicating. So now, right now, they're in the stateful set, right? Without memory, without persistence, 0, 1, 2, and 3. The master goes down, and a new Redis server is brought in. Then before it is brought in, we have 3 slaves already with 5 GB, 5 GB, and this guy is the most current one, okay? So he is the elected one. So this is a new container which Kubernetes will bring up. When it is bringing up, it will try to elect a new master here because it knows that there is no master. And then the moment it elects the master, it will say that this is my new master, and then it will automatically connect to the new master, and it will also reconfigure all these slaves to the new master, which is very important, right? So this is the new master, this will replicate from the new master. All these slaves will also now point to the new master. So this is configured in the init containers. So I have raised a PR to contribute to the community. Hopefully it gets accepted.
One question. So here, the Sentinel that's running as a stateless set out of.
No, it's a part of the. I can show you the config. If my keyboard works.
Reboot.
So did it make sense, or it was like too fast?
Reboot.
Do you implement the election process using an
No. Redis Sentinel has an algorithm, a sequence of steps to actually elect a slave. So I just use the same algorithm. And then when I initially contributed, people from Google, they objected that you have taken the code from Redis, and do you have permission to do that? So I wrote to the guy who wrote Redis, Salvatore, I think his name. So I wrote to him, and he was like totally okay for now using it. So I have the permission now, obviously, to use the code. So this is the actual code for any control micro. And then I could.
Can you increase the font size? No. Not for me. Yeah.
So this is my stateful set specification. So here, for stateful set specification, you have to mention the service. That's a mandate. So without headless service, they call it headless service in Kubernetes. Without that, you cannot create a stateful set. So every single set in your stateful set would attach itself to the service. It will create a DNS entry so that it is discoverable among your stateful sets. So this is my service representation. So there is one other thing you should do when you are creating a service for stateful set is that you should mention this annotation. So Kubernetes wouldn't create a service if the actual underlying backend is not ready. So you should create this exception because most of the time there is a small lag for you to create the actual set because you have the containers downloading, you have something to do with the init containers. So your backend is not ready, but still the service would be created. So this would allow you to do that. So these are all the other basic specs like port configuration, name of the port. So I'm not going to go to that. And in this annotation, this is where I'm calling my Redis container micro, Redis Sentinel micro, which I renamed to Redis Sentinel K8s because we wrote it for K8s only. And I'm calling this init containers. And so if you see here, so you can call this Redis Sentinel micro or Redis Sentinel K8s with the name of the service. The name of the service would be the same thing that you gave here, right? So it simply supply the name of the service here, RD, and So what Redis Sentinel K8s would now do is it is going to go and look for your DNS records for this service name. So it would get all the other Redis instances like RD0, RD1, RD2. And then it will try to connect to them using the Redis CLI, and it will find out who's got the maximum up-to-date data. And then among them, it will use the same algorithm and it will elect a master. So once that is over, so for this, I couldn't answer Vasant's question that I've not used persistence at all. So I don't need persistence because the intention is to have something completely stay in memory. So once we elect a master, what we do is that we start the actual Redis, your Redis container. So the moment you start your Redis container, there is also a sidecar container we start, which is called as make Redis slave. So this would go and read the same mounted directory. It's a local empty directory which I'm mounting inside the init container. So I'm writing a config file. After selecting a master, this is the master. There are no masters, everything is completely altered. I'm going to write nothing. So this would write something, and then this sidecar container, make Redis slave, would then come up, and then it will find out this is the correct master, it will connect to the correct master. So Redis Sentinel Micro would also reconfigure all the other slaves that are already there in your stateful set to the new master. So sidecar container would just configure your new Redis app container which was just started. So the pet set for Redis that is available, the way it does currently is that it downloads your Redis source code, it tries to build the Redis in your current host, and then it starts your Redis container. So that is taking a little bit of time. You could actually change that to any Alpine Redis Docker image, which is like 7 or 8 MB and which downloads in like few seconds and it starts, which is pretty much straightforward. So I've already started a couple of Redis containers. Let me start one again. So this one, so let me start. So it created the service, then it created a pod description budget, and it created a stateful set. So we will talk about what the other two things are and why it is important for it when you're configuring a stateful set shortly. So this is cache 0. So it started normally. So as you can see that it is starting things in sequence. So initially it started case 0, but this is not the behavior for replica set or daemon set or any other controller. Everything is trying to, everything is started in parallel. But for stateful set, this is started in sequence because you get more control. And this is what it was missing, Kubernetes was missing like a year ago. So we get pods, so we got 3 Redis stateful sets. Now if I describe so you can see that this is actually 2. See that we have started all the containers. This is the sidecar container, and our Redis Sentinel Sentinel K8 has started, completed the initialization, and then we started Redis Alpine. Yeah, here. So Redis 3.2 Alpine container too. So I would really like to show you how you set a key and then kill the master, how the election happens, but I don't think that is the focus of the discussion. But you could try the moment it gets merged into Kubernetes, you could try it. It will be open source. So coming back to the topic, the current state is that the whole pet set is now completely rewritten as a stateful set. Recently, it's like a week or 2 before it got merged into mainstream Kubernetes. And there has also been a request to relax the tendency of stateful set being started sequentially, because there are some stateful applications which needs parallel start, but they are also stateful in nature. So that rule is now being relaxed. So they are going to bring in a new annotation or a new configurable or tunable where you could configure that. And then there was a debug annotation before, which would, the moment you set the debug annotation, it would start each and every set, and then The moment you are really sure that that set is pakka, it's all up and running, then you could go and update it. So the next replica in the stateful set would be started. So now that is being removed. It was originally an experiment, and now it is being removed. So more focus is currently in the stateful set is on stabilizing the stateful set because it's fairly new to Kubernetes. And then they're trying to convert all. How many of you know Helms and charts here? I strike charts. So there has been some effort to move all the charts, stateful charts, or charts running stateful applications like MongoDB, MySQL, to stateful sets, so that we get more errors and then make this stable. So as I mentioned before, stateful set and friends. I mean, if you are creating a stateful set, it's very important that you do other things. You create other Kubernetes entity also to make it work really well. I mean, one is service, it's mandatory. Without service, you cannot create a stateful set. The other one is init containers. I mean, if you have anything to initialize, please exploit this. Init containers are very useful, as you saw in Redis Sentinel case. And then the other one is pod disruption budget. So if you have a stateful set with a lot of replicas, and then you're doing some maintenance on your Kubernetes cluster itself, then how long? What is the tolerance level of Kubernetes to let the disruption of your stateful set? Say your original stateful set has got 10 replicas, then the maximum number of replicas that Kubernetes can bring down during maintenance is 3. Beyond 3, it cannot bring down. So you can set such type of constraints using pod disruption budget. So some of the examples right now, they all have pod disruption budget, so you could use it. It's very easy to configure it. And one other thing, without saying, which goes with stateful set is that interpod affinity and interpod anti-affinity. So if your application is stateful in nature, right, it would either be master or slave, or it would be shards, or it would be something that is really busy, right? So what is the point in co-locating these stateful set or sets in the same node? They need to be distributed across the cluster, right? So you should, in my opinion, have anti-affinity configured default in all the stateful applications. As a matter of fact, I raised an issue in the Kubernetes community, but it was declined because people foresee that there could be some use cases where you might need stateful applications running in the same node, but I couldn't see any use case of that. The other one is config map. Config map is just a key value representation of any config, like your environment variable, your app name, anything that would be useful throughout your stateful set, across your application, throughout your YAML configuration. So that is something most of the stateful set designers use it. The goal of stateful set itself is that anybody should be able to deploy stateful applications in Kubernetes without having to be a distributed systems engineer. Right? You don't have to do all these things. It should be very simple. So that is the goal, but it is not. We are not there yet. So we might be there in like a few years. So you saw the demo. And stateful set roadmap is that currently, just like deployments, there should be some solid path for rolling upgrades for stateful set. So you might want to change your Redis image version. So you should be able to do that. And then currently, the only field that you could do update on the stateful set spec is your replicas. So you could scale up and scale down. So people are planning to relax that once the upgrade is over. So you might be able to update any of the field in the stateful set. So you can probably change the volume,